So good morning dear students. So the next chapter what we are discussing here, that is called as a system of particles. So in that one, system of particles, in that one we are going to discuss basic definition about the rigid body, so which is called as rigid body. So now for example, if I consider this is a body, say this is a body, and here we are going to observe many number of the molecules like this. So here we observe many number of the molecules like this. For example, if I consider a distance between these two molecules, and again if I consider distance between these two molecules, again if I consider distance between these two molecules like this, if we consider any number of the molecules, so if we consider any number of the molecules, their distance never changes. So their distance, what happens here, never changes even though we apply external forces. Even though we apply external forces, distance between the two molecules, what we observe here, this never changes. That kind of a body we call as a rigid body. So that kind of body we consider as a rigid body. So in the sense, so ಯಾವುದೇ ಎರಡು ಮಾಲಿಕ್ಯುಲರ್ ಅಥವಾ ಆ ಬಾಡಿ ಒಳಗಿರೋ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆದರೂ ಕನ್ಸಿಡರ್ ಮಾಡ್ರಿ, ಆ ಎನ್ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಒಳಗಿರೋ ಆ ಪಾರ್ಟಿಕಲ್ ನಡುವೆ ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ಸೊ ಅದು ಯಾವಾಗೂ ಚೇಂಜ್ ಆಗಿಲ್ಲ. ಸೊ ಇವನ್ ದೋ ವಿ ಅಪ್ಲೈ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸಸ್ ಆಲ್ಸೋ, ದಿಸ್ ನೆವರ್ ಚೇಂಜಸ್ even though we apply external forces also. So that's the reason we consider such kind of a body as a rigid body. So rigid body in the sense, remember, the distance between different molecules, so distance between different particles of a given body never changes even though we apply what here, external forces. So that kind of a body we consider as a rigid body. Next, so what is called as a axis of a rotation, so which is called as a axis of a rotation. For example, if we consider this is a body, so we have taken this as a body here, and in this body, so this is a line along which, so this is a line along which a body rotates, so the line along which the body is fixed. For example, if I consider this is any one of the body like this, if we assume this is a body, and here we are going to observe a line along which, the line along which this body is fixed, or else the rigid body is fixed there. So that kind of a line we consider as axis of rotation, that we consider as a axis of a rotation. For example, if I consider this as a axis of rotation, this body, what we observe, this body has been fixed here. So this body has been fixed along this particular line. So ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಲೈನ್ ಥ್ರೂ ಏನಾಗಿರುತ್ತೆ, ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿರೋ ರಿಜಿಡ್ ಬಾಡಿ ಫಿಕ್ಸ್ ಆಗಿರುತ್ತೆ. ಯಾವ ಲೈನ್ ಥ್ರೂ ಕನ್ಸಿಡರ್ ಮಾಡಿರೋ ರಿಜಿಡ್ ಬಾಡಿ ಫಿಕ್ಸ್ಡ್ ಆಗಿರುತ್ತೆ, ಆ ಲೈನಿಗೆ ನಾವೇನು ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ, ಎಕ್ಸಸ್ ಆಫ್ ರೊಟೇಷನ್. ಅದಕ್ಕೆ ನಾವು ಎಕ್ಸಸ್ ಆಫ್ ರೊಟೇಷನ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. Now, so if I consider this as a axis of a rotation, there are the two possibilities of a motion. The first type of a motion we consider as a translation, or it's a translatory motion. The first type of a motion of a rigid body we observe, that is given by a translatory motion. And the second type of a motion of a body that we consider given by a rotational motion. So rotational motion of a rigid body. Now, so if we observe two types of a motion, there we are going to observe the first one, translatory, so which is called as a translatory. For example, if I consider this is a rigid body, in this rigid body we are going to observe n number of particles. So here we observe n number of particles. whenever we observe pure translationary, so or it's pure translatory motion, so when we observe pure translatory motion, there we are going to observe, so there we are going to observe, so here velocity of all the particles or velocity of the all the rigid body, or is a velocity of particles of a rigid body that remains always constant. So this we consider as a pure translatory motion. So in the pure translatory motion, we are going to observe every particles of a rigid body. So every particles of a rigid body are executing same amount of what? Velocity. So that all kind of a motion we consider a pure translatory motion. So pure translatory motion. Similarly, when we observe here pure rotational motion, so when we observe here a pure rotational motion, so what happens in this particular rotational motion? Let us see. So here we are going to observe axis of rotation. So if I consider this is axis of rotation for a given object like this, or for a given rigid body like this. In that one, every particle, let us assume this is a first particle, it is making in a circular path. So every particle in pure rotational motion, so every particle so is moving in a circle, so is moving in a circle, and this has a fixed center. So this has a center which is fixed on the axis of a rotation. For example, if I consider the first particle, so first particle is moving in a particular circular path such that its center lies on the axis of a rotation. Now the second particle, ಈಗ second particle ನ consideration ಮಾಡೋಣ. So ಇದು second particle consider ಮಾಡಿದ್ರೆ second particle center again ಆ second particle ಯಾವ ಮೂವ್ ಆಗಬೇಕು, ಯಾವ ಸ್ಟೇಟ್ ಒಳಗೆ ಮೂವ್ಮೆಂಟ್ ಆಗಬೇಕಂತಂದ್ರೆ again it is in a circular path because rotational motion you are going to observe, again it is moving in a particular circular path. So but again the condition is what? Second particle is also having the center fixed on what here? Axis of a rotation. So it is also again fixed on what here? Axis of a rotation. So ಇದನ್ನ ಏನು observe ಮಾಡ್ತೀರಿ? Axis of a rotation ಮೇಲೆ fixed ಇರೋದನ್ನ ಈ ರೀತಿ observe ಮಾಡ್ತೀರಿ. Like this, we can say this is a plane. So plane of a molecules, or is a plane of a particles. So plane of a particles is perpendicular. So is perpendicular to what here? Axis of a rotation. So if this is a plane of a particle and is perpendicular to the axis of a rotation. So in pure rotational motion, every particle rotates in a particular plane. So every particle rotates in a particular plane which is perpendicular to the ಯಾವ ಪ್ಲೇನ್ ಒಳಗೆ rotate ಆಗುತ್ತಂದ್ರೆ, so pure rotational motion ಒಳಗೆ ಆ ಎಲ್ಲಾ ಪಾರ್ಟಿಕಲ್ ಒಂದು particular plane ಒಳಗೆ rotate ಆಗುತ್ತೆ. ಯಾವ ಪ್ಲೇನ್ ಒಳಗೆ rotate ಆಗಿರತ್ತಂದ್ರೆ ಆ ಪ್ಲೇನ್ particular axis of rotation ಏನಿರುತ್ತೆ? perpendicular ಇರುತ್ತೆ. If it is a axis of rotation here, this is a plane. So ಈ ಪ್ಲೇನ್ ಒಳಗೆ ಏನಾಗುತ್ತೆ? ಎಲ್ಲಾ particles rotate ಆಗುತ್ತೆ. So it should have rotated in a particular plane which is perpendicular to what here? Axis of a rotation. Next, ಆ rotate ಆಗುವಾಗ ಒಂದು ಕಂಡೀಷನ್ ಅಂತಂದ್ರೆ ಆ ಎಲ್ಲಾ ಪಾರ್ಟಿಕಲ್ ಸೆಂಟರ್ ಏನಿರುತ್ತ ಆ ಪಾರ್ಟಿಕಲ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಒಳಗೆ ಏನ್ ಸೆಂಟರ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ ಆ ಸೆಂಟರ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಕ್ಸಿಸ್ ಆಫ್ ರೊಟೇಷನ್ ಮೇಲೆ ಪ್ರೆಸೆಂಟ್ ಇರಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ಅ ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್. So that kind of a motion we consider as a pure rotational motion. So pure rotational motion in the sense it is rotating like this. So it is rotating like this and it is having a plane like this, and this plane should be perpendicular to the axis of rotation, and all the molecules or all the particles should have the center which should lie on this axis of a rotation. So that we consider as a axis of a rotation here. So in the axis of rotation, there again you are going to observe every molecules or every particles should move with the same amount of angular velocity. So this is what important quantity. So every particles, they are moving with the constant amount of angular velocity. So this is a condition when we observe for the pure rotational motion. When we observe for the pure translational motion, there we are going to observe every particles are moving with the same linear velocity. But when we consider pure rotational motion, every particle is moving with the angular amount of or same amount of angular velocity. So this is a difference. When we observe pure rotational motion, it is having a plane in which all the particles are rotating with a center fixed on the axis of a rotation. But there you are going to observe for a linear translatory motion, there is a fixed amount of what center on the axis of a rotation or not. So but yaವಾಗ ನಾವು ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಮೋಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ ಆ ಪಾರ್ಟಿಕಲ್ ಒಳಗೆ ಅಥವಾ ಆ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಮೋಷನ್ ಇನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ ಆ ರಿಜಿಡ್ ಬಾಡಿ ಒಳಗೆ ಎಲ್ಲಾ ಪಾರ್ಟಿಕಲ್ ಸೆಂಟರ್ ಏನಾಗಬಹುದು ಆಕ್ಸಿಸ್ ಆಫ್ ರೊಟೇಷನ್ ಮೇಲೆ ಬರಬಹುದು ಬರ್ಲಿಕ್ಕಿಲ್ಲ. ಸೊ ಮೇ ಆರ್ ಮೇ ನಾಟ್. ಬಟ್ ದ ಕಂಡೀಷನ್ when we observe pure rotational motion, the condition should be compulsory. A plane should be perpendicular to what here? Axis of a rotation, and in that plane all the particles should move in a circular path, and all the particles should have the center which lies on the axis of a rotation. So this is about the axis of a rotation here. So there we observe two type of the motion. Next, so after getting axis of rotation, now we are going to observe what is the meaning of a center of mass. So center of mass, and there when we apply for the two particles and when we apply for the n number of particles, let us assume. So here we are going to observe a center of a mass is a point. If this is a rigid body, let us assume this is, we consider a rigid body. So rigid body ಅಂತಂದ್ರೆ already observe ಮಾಡಿರಿ, distance between the different molecules never changes even though we apply external forces here. Now if this is a rigid body, there we observe center of a mass. So what is the meaning of a center of mass here? Now we can say this is a center of mass. If I say this as a center of mass, the condition is at this particular point, whole mass of the body should concentrate. So that we consider as a center of mass. Andre no ee point ಏನು ನಾವು center of mass of a rigid body ಅಂತ ಹೇಳಿ ಅಂತಂದ್ರೆ ಆ ಪಾಯಿಂಟ್ ಒಳಗೆ ಏನಿರಬೇಕಂತಂದ್ರೆ whole mass of the rigid body concentrate ಆಗಿರ್ಬೇಕು. So entire mass of the rigid body ಆ particular point ಒಳಗೆ concentrate ಆದ್ರೆ, so ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀರಿ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್. ಸೊ ದಟ್ ವಿ ಕನ್ಸಿಡರ್ ಆಸ್ ಅ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್. For example, if we have the two particle system, let us assume here we are going to observe a rigid body. So ಇದೊಂದು rigid body ಅಂತ ತಿಳ್ಕೊಂಡಾಗ ಅದರೊಳಗೆ ಏನು ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಿರಿ, two particles. So here the two particles which are separated by a particular distance like this. Now first particle which is having a mass of m1, and the second particle which is having a mass of m2, and the first particle is at a distance of vector r1. So it is at a distance of vector r1 from the origin. So from the origin, let us assume we consider as a coordinate system here. So when we have a coordinate system, so there we are going to observe a coordinate system like this. So we will apply a coordinate system. When we apply a coordinate coordinate system here. Now from the origin, the first particle which is at a distance of vector r1. So this is the first particle having a position vector given by vector r1 from the origin. So from the origin we are going to observe vector r1 is the position vector of the first particle. Similarly, we can say second particle which is at a distance of vector r2, which is at a distance of vector r2 from the origin. So now we can say second particle is having position vector r2 from the origin. So this is the quantities when we consider a system of only two particles. So here we are going to consider a rigid body in which only the presence of two particles. So that's what we can write vector r1, which is a position vector corresponding to the first molecule or is first particle. Similarly, so vector r2 position vector corresponding to the second particle. Now when we observe a center of a mass, so center of a mass which is given by a vector RCM. So vector RCM, when we write the equation, that is given by first molecule is having a mass of m1 and having a position vector given by vector r1, and the second particle having a mass given by m2 and position vector given by vector r2 divided by, so divided by, again we can write some mass of the first particle given by m1 plus mass of the second particle given by m2. So this is the equation when we observe corresponding to the system of particles with the two masses here. Now, so if we consider this is having a system of particles, so system of particles which is having only two particles here. Now the same equation, if we have two masses are having, or two particles are having a same amount of a mass. So whenever two particles are having a same amount of mass, now center of a mass, so center of a mass vector RCM, that is given by m multiplied by vector r1 plus, so here m is a common term, we can take outside vector r1 plus vector r2, again divided by 2 times of m. So here m and m get cancelled. Now we can say the center of a mass that will be equals to vector r1 plus vector r2, again divided by 2. So this is an equation corresponding to what here, a center of a mass. So what is the meaning of this one? Let us see. Practically when we observe a center of a mass, what equations you are going to observe, we will show in the form of a practically. Let us see. Suppose this is any one of the rigid body. So if any one of the rigid body like this. Now if we want to balance this rigid body, so let us assume here we are going to observe only two particles which are having a same amount of the masses. For example, we are going to tie object 1 for this one like this. ಇಲ್ಲಿ ಅಂದ್ರೆ ಯಾವುದೊಂದು ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ಈ ರೀತಿ ಟೈ ಮಾಡಿರಿ ಅಂತ ತಿಳ್ಕೊಂಡು, ಸೊ ಇಲ್ಲಿ ನೀವು ಏನು ಮಾಡ್ತೀರಿ, ಸೆಕೆಂಡ್ ಆಬ್ಜೆಕ್ಟ್ ನ ಈ ರೀತಿಯಲ್ಲೂ ಟೈ ಮಾಡಿರಿ. ಸೊ ಈ ರೀತಿ ಟೈ ಮಾಡ್ತೀರಿ. ನೆಕ್ಸ್ಟ್ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಏನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿರಿ, so both are having same amount of the mass. So both are having same amount of the mass. Now so if I want to balance this one, so ಈಗ ನಾವು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕಂತಂದ್ರೆ, ಎರಡು ಸೈಡ್ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಯಾವ ಪೊಸಿಷನ್ ಒಳಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಅಟ್ ದ ಮಿಡಲ್ ಆಫ್ ದಿಸ್ ಪಾರ್ಟಿಕಲ್, ಅಟ್ ದಿ ಮಿಡಲ್ ಆಫ್ ದಿಸ್ ಟು ಆಬ್ಜೆಕ್ಟ್ ಹಿಯರ್. ಯಾಕಂತಂದ್ರೆ ಈ ರೀತಿ ನೀವು ಟೈ ಮಾಡಿ ಬ್ಯಾಲೆನ್ಸ್ ಅನ್ನ ಚೆಕ್ ಮಾಡಿದಾಗ ಎರಡು ಬ್ಯಾಲೆನ್ಸ್ ಬರಬೇಕಂತಂದ್ರೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಎಲ್ಲಿ ತಗೋತೀರಿ, ಮಿಡಲ್ ಅನ್ನ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ. ಈ ಮಿಡಲ್ ಅನ್ನ ಯಾವ ರೀತಿ ಬರಿಬಹುದು ಅಂದ್ರೆ ನಾವು, ಸೊ ದಿಸ್ ಈಸ್ ವೆಕ್ಟರ್ ಆರ್ ಸಿ ಎಂ. RCM. So vector RCM that is equals to vector R1 plus vector R2 divided by 2 here. Yakantandre, so again you are going to observe, if I apply the coordinate system, object 1. So object 1 is at a distance of what here? Vector R1. Second object is at a distance of what here? Vector R2 from the origin. So origin ದಿಂದ ಈ particular distance ಅನ್ನು observe ಮಾಡಿರಿ. ಎರಡು ಪಾರ್ಟಿಕಲ್ ಗೆ ಸೇಮ್ ಮಾಸ್ ಇದ್ದಾಗ, ಎರಡು ಪಾರ್ಟಿಕಲ್ ಗೆ ಸೇಮ್ ಮಾಸ್ ಇದ್ದಾಗ, ಈ ರೀತಿ ಎರಡು ಪಾರ್ಟಿಕಲ್ ಗೆ ಸೇಮ್ ಮಾಸ್ ಇದ್ದಾಗ ಆ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ 1 ಅಂಡ್ ಆಬ್ಜೆಕ್ಟ್ 2 ಎರಡನ್ನೂ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಯಾವ ಪಾಯಿಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿರಿ? ಸೆಂಟರ್ ಆಫ್ ದಿಸ್ particular distance here. So center between these two particles here. So that is what we can say, it is a point. ಅದಕ್ಕೆ ನಾವೇನ್ ಡಿಫೈನ್ ಮಾಡ್ತೀರಿ? ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಅಂದ್ರೆ it is a point. It is a point. ಈ ಪಾಯಿಂಟ್ ಒಳಗೆ, so it is a point. ಈ ಪಾಯಿಂಟ್ ಒಳಗೆ whole or is entire mass of the body is concentrated. ಈ ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನು ನಾವು ಹೋಲ್ಡ್ ಮಾಡಿದ್ರೆ ಆ ಎಂಟೈರ್ ಸಿಸ್ಟಮ್ ಅನ್ನು ನಾವು ಏನ್ ಮಾಡಿದಂಗ ಆಗುತ್ತೆ? ಹೋಲ್ಡ್ ಅಪ್ ಮಾಡಿದಂಗ ಆಗ್ತದೆ. ಅದಕ್ಕೆ ನಾವು ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಅಂತ ಹೇಳ್ತೀರಿ. ಯಾವಾಗ ಡಿಫೈನ್ ಮಾಡ್ತೀರಿ? ಇಟ್ ಈಸ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್. ಸೊ ಇಟ್ ಈಸ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಇನ್ ವಿಚ್ ಎಂಟೈರ್ ಸಿಸ್ಟಮ್ is going to concentrated. So it is a point in which entire system is going to concentrate here. So that is what we can say a center of mass here. Now, so when we apply for n number of particles, so it is applied only for what here? 2 particles. But when we apply for n number of particles, a center of mass is given by. So because we are going to observe n number of particles, whenever we have n number of particles, a center of mass that is given by RCM, vector RCM, that is equals to corresponding to the first particle given by m1 multiplied by vector r1. So this is m1. ಯಾಕಂದ್ರೆ ಫಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ, ಸಿಸ್ಟಮ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಿದಾಗ, ಇಫ್ ದಿಸ್ ಇಸ್ ದ ಫಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ಅಂಡ್ ಹ್ಯಾವಿಂಗ್ ಅ ಡಿಸ್ಟೆನ್ಸ್ ಫ್ರಮ್ ದ ಒರಿಜಿನ್ ಅಂದ್ರೆ ಇಲ್ಲಿ ಯಾವ್ದಾಗುತ್ತೆ? ಪಾರ್ಟಿಕಲ್ಸ್ ಒಳಗೆ ಒರಿಜಿನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಎಕ್ಸಸ್ ಆಫ್ ರೊಟೇಷನ್. ಸೊ ಎಕ್ಸಸ್ ಆಫ್ ರೊಟೇಷನ್ ನ ಈ ರೀತಿ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ. ಸೊ ದಿಸ್ ಈಸ್ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಸೇ ಎಕ್ಸಸ್ ಆಫ್ ರೊಟೇಷನ್ ಇನ್ ದ ಸಿಸ್ಟಮ್. And first particle is having a mass of what here? m1, and second particle having a mass of what here? m2, and having position vector given by r2, and similarly third particle having a mass of what here? m3, and it is having a radius vector given by vector r3. So like this we are going to observe n number of particles. ಈ ರೀತಿ ನಾವು n number of particles ಅನ್ನು consideration ಮಾಡಿದ್ವಿ. So when we have n number of particles, m1 vector r1 plus m2 vector r2, like this we are going to observe nth particle mn and having a radius of vector given by vector rn divided by masses of the individual particles. So masses of individual particles m1 plus m2 plus m3, like this the last particle having a mass given by mn. So this is the equation corresponding to what here? A center of a mass. So this is the equation corresponding to what here? A center of a mass when we have n number of particles. Whenever we have n number of particles like this. The next here we are going to observe what are the properties of this center of a mass. So when we observe the properties, so we can say if it is only along the x-axis. So whenever we are going to observe it is only along the x-axis, we can write summation, because we are going to observe n number of particles from I is equal to 1 into what here? N number of particles. So summation of I is equal to 1 to n number of particles. In that one we can say mi multiplied by vector ri, again divided by, so summation we can write mi. So I in the sense I can take the I value from a 1 into what here? N number of molecules. So that we can write summation of I is equal to 1 to the n value, that is given by mi multiplied by ri, again divided by, so divided by whole mass of the rigid body, or else masses of individual particles. So masses of individual particles, that is given by m1 plus m2 plus m3. Like this we have n number of particles, so that we can write total mass given by m value. So this is the equation corresponding to what here, only along the x-axis. So if remember, center of mass is distributed along the x-axis, we can write this is the equation. ಅದೇ ರೀತಿ y-axis ಒಳಗೆ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಏನಾದರೂ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದ್ರೆ, ಸೊ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆದಾಗ ಅದನ್ನೇನು ಬರೀತೀರಿ, ಸೊ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ along the y-axis we can write again summation I is equal to 1 to the n multiplied by, so mi vector ri divided by, so divided by total mass of the rigid body, that is given by m value. So this is the distribution of center of mass along the x-axis, distribution of center of mass along the y-axis. Now, so distribution of center of mass along the z-axis, that can be written as ZCM. That will be a summation I is equal to 1 to the n number of particles. Now we can write mi ri vector ri again divided by total mass of the rigid body. So total mass of the rigid body. So this is, we can say, center of mass distributed along the x-axis, y-axis, and similarly along the what here, z-axis. So these are the equations corresponding to what we can say coordinate system. So this is the equations corresponding to what here, a center of a mass. So equation corresponding to the center of a mass along what here, a coordinate axis here, athwa coordinate system. So whenever a system of particles is under a coordinate system, we can observe a center of mass along the coordinate axis like this. Now, so if we are going to observe, it is distributed uniformly. Whenever it is distributed uniformly, there we can write the center of mass, that is given by, so center of mass along the, so center of mass along the x-axis, that will be 1 by x, and the entire amount of the values, the entire amount of a value, that will be r. So this is the equation whenever we are observing a continuous distribution. Sorry, so this is along the x-axis we are writing, so center of mass along the x-axis, that will be 1 divided by m, and here distributed only along the x-axis, or else continuously distributed along the x-axis. Next, if it is continuously distributed along the y-axis, we can write 1 divided by m integration of y value, and this is along the axis. Yav axis anna consider madire, y-axis, and what we consider a dm. So because mass is distributed continuously, so mass is distributed continuously, that is what we can write, ycm is equal to 1 by m integration of y dm value. And similarly, if it is continuously distributed along the z-axis, we can write 1 divided by m, and integration, that will be taken as z dm. So this we consider second property. So first property, coordinate axis athwa coordinate a system of particles applied to what here, a coordinate system, that was the first property. Next, the second property, here we are going to observe continuous distribution. Whenever we have continuous distribution, these are the equations. So this is second property regarding what here, a center of mass. Next, the third property, here we are going to observe whenever if the system, so third property, remember center of mass is, so center of mass is always independent of a choice of a origin, so choice of a coordinate system. We can say it is always independent, it is always independent of what here, a choice of a coordinate system. So this is independent of a choice of a coordinate system here. So coordinate system ನೀವು ಎಲ್ಲಾದರೂ ಫಿಕ್ಸ್ ಮಾಡಬಹುದು. So we can fix anywhere, it is independent of what here, a choice of a coordinate system. So it's the third property regarding what here, a center of mass. Next, the fourth property, when we observe here, so this is depending on shape of the body. So it is depending on a shape of the body and also distribution of a mass. So it is very important here. So here a center of mass depends always, the first one shape of the body, and here the shape of the body along with that one distribution of the masses here. So distribution of masses, ಯಾವ ರೀತಿ ಆ ರಿಜಿಡ್ ಬಾಡಿ ಒಳಗೆ ಪ್ರತಿಯೊಂದು ಪಾರ್ಟಿಕಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗ್ಯದ. ಸೊ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ನಾ ಇದೊಂದು ರಿಜಿಡ್ ಬಾಡಿ ಕನ್ಸಿಡರ್ ಮಾಡಿರಂದಾಗ ಈ ರಿಜಿಡ್ ಬಾಡಿ ಒಳಗೆ ಆ ಪಾರ್ಟಿಕಲ್ಸ್ ಯಾವ ರೀತಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆಗಿದೆ, ಇದ್ರೊಳಗಿರೋ ಎಲ್ಲ n ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಯಾವ ರೀತಿ ಮಾಸಸ್ ಅನ್ನ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಮಾಡ್ಕೊಂಡಿದೆ, ಆ ಬೇಸ್ ಮೇಲೆ ನಾವೇನಂತ ಹೇಳ್ಬೋದು, ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಫಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ಮಾಸ್ m1 ಅಂತ ತಿಳ್ಕೊಂಡು, ಸೆಕೆಂಡ್ ಪಾರ್ಟಿಕಲ್ ಮಾಸ್ m2 ಅಂತ ತಿಳ್ಕೊಡ್ರಿ, and third particle mass m3, like this. If I consider this is a rigid body 1, say the rigid body 1 as assumption mode. Again I will consider one more rigid body, so second rigid body. In that such way there we can observe m1 is greater than m2, andre first particle is gaining more amount of a mass compared to what here, second particle, when I observe the first rigid body. Now so when we observe the second rigid body, there we can observe first particle, let us assume, is having a less amount of a mass compared to what here, first particle. So yawaga first rigid body ಒಳಗೆ mass distribution ಆಗಿರೋದು ಯಾವ ರೀತಿ ಅದ ಅಂತಂದ್ರೆ first particle mass second particle mass ಗಿಂತ ಗ್ರೇಟರ್ ಅದೇ. ಅದೇ ರೀತಿ ಸೆಕೆಂಡ್ ರಿಜಿಡ್ ಬಾಡಿ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಿದಾಗ ಫಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ಮಾಸ್ ಸೆಕೆಂಡ್ ಪಾರ್ಟಿಕಲ್ ಮಾಸ್ ಗಿಂತ ಲೆಸ್ಸರ್ ಅಮೌಂಟ್ ಇರೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ. ಸೊ ದಟ್ಸ್ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಸೇ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಇಸ್ ಡಿಫರೆಂಟ್ ಫಾರ್ ದಿ ಡಿಫರೆಂಟ್ ಅಮೌಂಟ್ ಆಫ್ ರಿಜಿಡ್ ಬಾಡೀಸ್. ಸೊ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಇಸ್ ಡಿಫರೆಂಟ್ ಫಾರ್ ಡಿಫರೆಂಟ್ ರಿಜಿಡ್ ಬಾಡೀಸ್. ಸೊ ದಟ್ ಇಸ್ ದ ರೀಸನ್. ಸೊ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ವಾಟ್ ಶೇಪ್ ಆಸ್ ವೆಲ್ ಆಸ್ distribution of the masses here. So this is about the fourth property regarding what we can say a center of a mass. Next, the fifth property, again there we are going to observe if symmetrical distribution, whenever we have a symmetry about the rigid body, so symmetry about the rigid body and distribution is homogeneous. So whenever we are going to observe a rigid body with the symmetrical contribution, or else whenever we observe a rigid body it is having a symmetrical shape, and whenever we are going to observe a distribution, so there we observe a distribution is homogeneous, then in that cases we are going to observe center of mass is coinciding with, so coinciding with what here, geometrical center of a body. Whenever we are going to observe, for example if I consider like this, ಇದನ್ನ ಒಂದು triangle shape ಒಳಗೆ ಒಂದು rigid body ಅದಂತ assumption ಮಾಡೋಣ. So whenever it is in the triangle shape, in that one we can say this is the center of a triangle. ಇದೇನ್ ಪಾಯಿಂಟ್ ಏನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿರಿ, ಈ ಪಾಯಿಂಟ್ ಏನಾಗಿದೆ center of a triangle. So ಈ ಸೆಂಟರ್ ಗೆ ಏನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ, this we consider as a geocentric, ಅಥವಾ ಆ ಪಾರ್ಟಿಕಲ್ ಅಥವಾ ಆ ರಿಜಿಡ್ ಬಾಡಿ ದ ಸೆಂಟರ್ ಅಂತ ಹೇಳಿದೆ. So center of what we can say a rigid body. So this is what we observe, a center of a rigid body. Now if it is, so ಇದು ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, symmetrical shape ಅದ. So this shape what we observe here, a shape of a rigid body is symmetrical, and here we are going to observe a distribution of the particles. So distribution of the particles, that is we consider homogeneous. So distribution of the particles we consider homogeneous. ಅಂದ್ರೆ ಇಲ್ಲಿ ಎಷ್ಟು ಈ ಶೇಪ್ ಒಳಗೆ ಅಥವಾ ಈ ಪಾರ್ಟ್ ಒಳಗೆ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಬಂದಿರುತ್ತೆ ಅಷ್ಟೇ ಅಮೌಂಟ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಈ ಪಾರ್ಟ್ ಒಳಗೆ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾರೆ. ಸಿಮಿಲರ್ಲಿ ಅಷ್ಟೇ ಅಮೌಂಟ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇಲ್ಲಿನೂ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾರೆ. So it means that kind of a distribution we consider as a homogeneous distribution. Whenever we have homogeneous distribution and whenever we have a shape of the body as symmetrical, then this is what we can say geometric center. ಅಂದ್ರೆ ಆ ಬಾಡಿ ಒಳಗಿರೋ ಸೆಂಟರ್. ಸೊ ಜಿಯೋಮೆಟ್ರಿಕ್ ಸೆಂಟರ್, ಆ ಜಿಯೋಮೆಟ್ರಿಕ್ ಸೆಂಟರ್ ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ coinciding ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಸೇ center of mass of a rigid body as well as geometric center of a rigid body. So this is going to happen here. So this is going to happen under this condition. ಈ condition ಇದ್ದಾಗ center of mass is coinciding with what here a geometric center of a rigid body. So this is one of the property of what here center of a mass. Next, so after getting properties of this center of a mass, now we are going to observe what is the velocity of a center of a mass here. So now when we have velocity of a center of a mass, that is given by, so that is given by remember again we are going to observe this is given by m1 vector r1. So m1 vector r1 plus m2 vector not r1, because first particle is having a velocity given by a vector v1, second particle is having a velocity given by vector v2. Like this we are going to observe for the nth particle that can be taken as a mn vector vn divided by, so divided by again we can write some mass of the first particle, mass of the second particle. Like this we can observe n number of the particles. So this is we can say velocity of the center of a mass. So this is what we can say velocity of what here center of the mass. ಅಂದ್ರೆ ಆ ಪಾರ್ಟಿಕಲ್ ಒಳಗೆ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿರಿ, ಆ ರಿಜಿಡ್ ಬಾಡಿ ಒಳಗೆ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿರಿ, ಆ ರಿಜಿಡ್ ಬಾಡಿ ಒಳಗೆ ಫಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ವೆಲಾಸಿಟಿ v1 ಬರೀತೀರಿ, second particle velocity vector v2 ಬರೀತೀರಿ, so third particle velocity vector v3 ಬರೀತೀರಿ. ಈ ರೀತಿ ಡಿಫರೆಂಟ್ ಇದ್ದಾಗ ಆ ಟೋಟಲ್ ವೆಲಾಸಿಟಿ ಆಫ್ ಅ ಸೆಂಟರ್ ಆಫ್ ಅ ಮಾಸ್ ಏನಾಗಿರುತ್ತೆ ಆ ಸಮ್ ಗೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಟ್ ಇಸ್ ವಿ ಕ್ಯಾನ್ ಸೇ, ದಟ್ ಇಸ್ ದ ರೀಸನ್ ವಿ ಕ್ಯಾನ್ ಸೇ ದಿಸ್ ಈಸ್ ಅ ಪಾಯಿಂಟ್ ವೇರ್ ಎಂಟೈರ್ ಮಾಸ್ as well as velocity is also concentrated. It is a point where entire mass as well as velocity of the rigid body is concentrated. Next, after getting now velocity of a center of mass, we are going to observe acceleration of a center of a mass here. Whenever we have acceleration of a center of a mass, that is again we can write, so first particle is having a acceleration given by a vector a1 and the second particle is having a acceleration given by vector a2. Like this we can observe for the nth particle having a mass mn and acceleration given by an again divided by, so divided by, now we can write so entire mass of the rigid body, so entire mass of the rigid body given like this. So this is the equation corresponding to what here acceleration of a center of mass. So this is corresponding to the acceleration of center of mass. Next, after getting these equations, now you are going to observe what is the meaning of an angular velocity. So angular velocity, which is called as a angular velocity. ಯಾಕಂತಂದ್ರೆ ರಿಜಿಡ್ ಬಾಡಿ ಒಳಗೆ ಟೂ ಟೈಪ್ ಆಫ್ ಮೋಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸೊ ದಿಸ್ ಇಸ್ ಇಫ್ ಇಟ್ ಇಸ್ ಅ ರಿಜಿಡ್ ಬಾಡಿ, ಇನ್ ದಟ್ ಒನ್ ವಿ ಅಬ್ಸರ್ವ್ ದ ಫಸ್ಟ್ ಟೈಪ್ ಆಫ್ ಮೋಷನ್ ದಟ್ ಈಸ್ ಗಿವನ್ ಬೈ ಟ್ರಾನ್ಸ್ಲೇಟರಿ. ಸೊ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಮೋಷನ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ. ಸೆಕೆಂಡ್ ಟೈಪ್ ಆಫ್ ಮೋಷನ್ ದಟ್ ವಿ ಅಬ್ಸರ್ವ್ ಆಸ್ ಅ rotational motion. So whenever we have a rotational motion, change in the position. So change in the position that is given in terms of what? Angular displacement. So that is given in terms of the angular displacement. ಯಾಕಂದ್ರೆ particle rotate ಆಗಿದಂದಾಗ, so this is the initial position. Now particle is under a rotational motion like this. It is coming in from the point A to what here? Point B, and it is making a angular displacement given by theta. So this we observe change in the position in terms of an angle. So whenever we observe change in the position in terms of an angle, that we consider as a angular displacement. ಇದಕ್ಕೆ ನಾವು ಏನು ಹೇಳ್ತೀವಿ? Angular displacement ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. Now, so in that one, rate of a change of, so rate of change of angular displacement with respect to time, that only we consider as a angular velocity. So rate of change of angular displacement, rate of change of angular displacement, or else a change of angular displacement with respect to certain amount of time, that we consider as angular velocity. So this is about the angular velocity. But ಇಲ್ಲಿ ಯಾವುದು observe ಮಾಡ್ತೀರಿ? Linear velocity ನ observe ಮಾಡ್ತೀರಿ. So this we observe as a linear velocity whenever we have a translatory motion. Whenever we have a rotational motion, we observe angular velocity. So angular velocity given by omega is equal to d theta divided by dt. Now the SI unit we can write radian per second. So radian per second is the SI unit corresponding to the angular velocity. Now what is the relation between this linear velocity as well as what here? Angular velocity. Remember angular velocity again we observe as a vector quantity. So then in observe ಮಾಡ್ತೀರಿ vector quantity ಇರೋದನ್ನ observe ಮಾಡಿ. So now what is the relation between linear velocity and one more we consider angular velocity? So I think we already observed this equation given by v is equal to r omega. So this is the equation corresponding to what here? V is equal to r omega, or else we can say vector r is equal to vector r cross vector omega. So because linear velocity is also vector quantity, and this will be considered as a displacement vector or its position vector, and this is also what we can say angular velocity is a vector term here. So this is a relation between angular velocity and this is linear velocity. Next, what about the angular acceleration? So now angular acceleration, it is defined as a rate of change of, so rate of change of angular velocity. So rate of change of angular velocity, that only we consider as a angular acceleration. Now SI unit is radian per second square. So we have the SI unit given by radian per second square. So these are the equations corresponding to what here? Angular velocity, and one more we can consider angular acceleration. So remember in pure translatory motion, so in pure translatory motion linear velocity is constant. So whenever we have a pure translatory motion, a linear velocity is always constant. Whenever we have pure rotational motion, so whenever we have pure rotational motion, there we are going to observe angular velocity remains always constant for all the molecules. So angular velocity remains constant for all the molecules when we have pure rotational motion. When we have pure translatory motion, there we observe a linear velocity for all the molecules, that remains always constant here. So this is a very important terms. Next, after getting angular acceleration, now you are supposed to observe what are the equations of this rotational motion here. So generally we have the linear equations that was given by v is equal to u plus a into t. So this was the first equation. So when we observe kinematic equations, so these were the equations. So v square is equal to u square plus 2as, and one more, s is equal to ut plus 1 by 2 at square. So this was the equations corresponding to what here? Kinematic equations. Similarly, when we have the rotational motion, there we are going to observe velocity. So this final velocity, linear velocity, you are going to replace it by angular velocity. So linear velocity, you are going to replace it by angular velocity, that will be omega. Next, initial velocity in case of a linear, that can be replaced in case of what here, angular velocity, that will be omega naught. Next, plus here acceleration, but here angular acceleration. So that's what we can write, omega is equal to omega naught plus alpha t. Now here v square, so in the sense we can write omega square is equal to omega naught square plus 2as. So 2as is there, we can write 2 times of alpha into, now we can say a distance as a s value. So this is the second equation. So when we observe a kinematic equations here, we can write the equations given by like this. Next, similarly when we observe, but the displacement here we are going to observe angular displacement, that will be theta. So then angular displacement olage observe martare, that will be in terms of theta. Again a theta is equal to omega naught into t plus 1 by 2 alpha t square. So this is okay. So here the next content that we consider moment of inertia. So which is called as a moment of inertia. So it is always denoted by a capital I. If this is, you are going to observe axis of a rotation. So if we are going to observe this as axis of a rotation. Now we will consider a rigid body like this, and in that one, when we observe the first particle which is having a mass of m1 and having a radius vector given by r1, and similarly so second particle having a mass of m2 value and having a radius vector given by r2 value, and here there you are going to observe a third particle which is having a mass of m3 and having a radius of vector given by r3. So because we already observed, when we observe a rigid body and when we have an axis of rotation, the center of all the molecules, so center of all the molecules, that should lie only on the axis of rotation. So that's the reason when we define a moment of inertia, it is nothing but, so it is nothing but sum of, so this is sum of a product of, so sum of product of masses and radius vector. So sum of product of mass of the particles and a square of the radius vector here. So this is, we are going to observe m1 r1 square plus m2 r2 square plus we can write m3 r3 square, like this we are going to observe for the n number of particles. So when we have n number of particles, now we are going to observe a moment of inertia I is equal to summation. So because sum, you are going to make a sum of all the particles, sum of, so sum of product of, so sum of product of mass of the particles and square of the radius vector. So square of the distance of a particle from the axis of a rotation, that we are going to observe mi ri square. So this is the equation. If we simplify further, we can write mr square. So this is the equation, we can say a moment of inertia. So moment of inertia is a very important property here. So because it depends on orientation of the axis of a rotation, position of a axis of a rotation, shape of the body, size of the body, and one more is a distribution of all the molecules within the particular rigid body here. So that is the reason so moment of inertia is one of the important property here. Next, after getting a moment of inertia, now we are going to observe what is the meaning of a radius of gyration. So, which is called as a radius of gyration. Now, again we are going to observe axis of rotation, and here we consider a moment, a rigid body, and here we are going to observe this is given by a rigid body here, and this we observe as axis of rotation. So, we are going to observe this as axis of rotation. So ಇದಕ್ಕೆ ನಾವು axis of rotation consideration ಮಾಡಿದ್ವಿ. Now, when we consider radius of gyration, so radius of gyration, it is nothing but a square of the distance. So square of the distance to the, so square of the distance from the axis of rotation to the center of a mass. So whenever we observe, it is a distance. It is a square of the distance between axis of rotation to the center of a mass. ಯಾಕಂದ್ರೆ center of mass ಅಂದ್ರೆ a point where entire mass of the rigid body is concentrated. So that's the reason when we define a radius of gyration, it is defined as a square of the, so square of the distance from axis of rotation to the center of mass here. So this is what we observe as a radius of gyration. So when we write a moment of inertia in terms of a radius of gyration, we can write I is equal to, so I is equal to mr square, ಅಥವಾ radius of gyration which is denoted by k value, illa antandre ಏನು ಬರೀತೀರಿ I is equal to mk square. So this is a moment of inertia in terms of what? A radius of gyration. Next, so what is the meaning of a torque? So which is called as a torque here. Now, whenever we have a rotational motion, so whenever we observe a rotational motion here, there we are going to observe axis of rotation, and here we are going to consider a rigid body. So in order to define the torque, there we are going to observe what are the conditions. So let us see, yavaga torque act aguttandre there should be two opposite forces. So there should be compulsory two opposite and equal forces. So first condition, there should be two equal forces, and the second one, here we observe two forces should act along the opposite direction. Andre no one force ee direction olige act adre innondu force opposite direction olige act agಬೇಕು. One force ಏನು ಬರೀತೀರಿ, some magnitude F1 and the second force magnitude F2. Now, so both forces should equal. So both forces should equal ಅಂದಾಗ F1 should be equals to what here? F2 value. So F1 should be equals to F2, and these two should be in the opposite direction. Then the quantity what we observe, this we consider as a effect of a force. So that we consider as effect of a forces. That effect of a forces, that only we call as a torque. ಅದಕ್ಕೆ ನಾವು ಏನು ಹೇಳ್ತಾರೆ, torque ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತಾರೆ. So torque means, remember, there we observe only the thing we consider as a effect of a forces here. So what is the effect of a forces? When two equal and opposite forces are acting on a rigid body. Whenever two equal and opposite forces acting on a rigid body, what are the effects you are going to observe here? So that effect only we consider given by a torque, and which is denoted by a tau value. So ಅದನ್ನ notation ಬರೀತೀರಿ, tau ಅನ್ನ notation ಬರೀತೀರಿ. Next, so the equation when we observe here a torque, that is given by a tau is equal to, so tau is equal to, so remember it is a vector quantity, vector tau is equal to, we can write vector f multiplied by vector r, ಅಥವಾ vector r cross vector f here. So if I write the magnitude, we can write a tau is equal to rf sin theta. So we can write the equation given by rf sin theta. So this is the equation corresponding to what here? A tau value. Next, what is the relation between toe and a moment of inertia अथवा torque and moment of inertia? So relation between a torque and one more is moment of inertia. So when we observe the relation there, it is given by a toe is equal to I alpha. So this is the equation. So when we observe here I alpha, so here this is a relation between a torque and one more is moment of inertia. So very important relation. So we should remember. Next, after getting a relation between torque and moment of inertia, now we are going to observe what is the angular momentum. So angular momentum that is given by vector L is equal to, it is denoted by L value and it is a vector quantity. Angular momentum, so vector L is equal to vector R cross vector P. So vector R cross vector P. So vector P in the sense that is nothing but, already we know here, this is called as a linear momentum. So this is be considered as a linear momentum. So already defined model. So linear momentum is a product of what here, mass and velocity. So linear momentum is again ಯಾಕಂದ್ರೆ ಇದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರ ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಎಫೆಕ್ಟ್ ಆಫ್ ಫೋರ್ಸ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡತ್ತೀರಿ. ಎಫೆಕ್ಟ್ ಆಫ್ ಫೋರ್ಸ್ ಅಂದಾಗ ಟಾರ್ಕ್ ಜೊತೆಗೆ ಎಕ್ಸ್ಟ್ರಾ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಏನಾದರೂ ಆಕ್ಟ್ ಆಯ್ತಂದ್ರೆ, ಸೊ ಇಫ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸರ್ವ್ ಟು ಅನ್ಈಕ್ವಲ್ ಫೋರ್ಸಸ್, whenever we observe two unequal forces, there is a possibility of what here, angular momentum. So that is the reason that we can consider, so there is a, along with the rotational motion, one more motion we are going to observe that we consider as a translational motion here. ಅಂದ್ರೇನು, ಈಗ ಆ ರಿಜಿಡ್ ಬಾಡಿ ಒಳಗೆ, ಸೊ ರಿಜಿಡ್ ಬಾಡಿ ಒಳಗೆ ಏನಾದ್ರೂ ನೀವು ಟಾರ್ಕ್ ಒಂದೇ ಆಕ್ಟ್ ಆಗಿತ್ತಂದ್ರೆ, ಸೊ ಟಾರ್ಕ್ ಒಂದೇ ಆಕ್ಟ್ ಆಗಿತ್ತಂದ್ರೆ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, ರೊಟೇಷನಲ್ ಮೋಷನ್ ಇರೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ದ ಫಸ್ಟ್ ಎಫೆಕ್ಟ್ ದಟ್ ವಿ ಕನ್ಸಿಡರ್ ಆಸ್ ವಾಟ್ ಹಿಯರ್, ರೊಟೇಷನಲ್ ಮೋಷನ್, ಓನ್ಲಿ ದ ಕ್ವಾಂಟಿಟಿ ಟಾರ್ಕ್ ಹಿಯರ್. ಬಟ್ ಆ ಟಾರ್ಕ್ ಆಕ್ಟ್ ಆಗ್ಬೇಕಂದ್ರೆ ಕಂಪಲ್ಸರಿ ಈಕ್ವಲ್ ಅಂಡ್ ಅಪೋಸಿಟ್ ಫೋರ್ಸಸ್ ಇರಬೇಕು. ಸೊ ಯಾವಾಗ ಈಕ್ವಲ್ ಅಂಡ್ ಅಪೋಸಿಟ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ, ಟಾರ್ಕ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಆ ಟಾರ್ಕ್ ಎಕ್ಸಿಸ್ಟ್ ಆದಾಗ ಯಾವ ಮೋಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ, ರೊಟೇಷನಲ್ ಮೋಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಸೊ ಫಸ್ಟ್ ಕಂಡೀಷನ್, ಸಪೋಸ್ ಫೋರ್ಸಸ್ ಆರ್ ಅನ್ಈಕ್ವಲ್. Suppose the forces are unequal. When we observe unequal forces, there is a possibility of what here, along with the rotational motion, one more motion that we consider as a translational motion here. Selene observe ಮಾಡ್ತೀರಿ, translatory motion exist ಆಗಿದ್ದು observe ಮಾಡ್ತೀರಿ. So this is a quantity along with what here, rotational motion. There is a quantity existed called as translatory. So whenever we have translatory motion, there is a quantity called as a linear momentum. So there the quantity existed called as a linear momentum. ಯಾವಾಗ linear momentum exist ಆಗುತ್ತೆ along with the rotational, there is a quantity called as what here, angular momentum. ಅದಕ್ಕೆ ಒಂದು ಟರ್ಮ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತಾರೆ, angular momentum. So angular momentum ಎಕ್ಸಿಸ್ಟ್ ಆಗಬೇಕಂದ್ರೆ rotational motion ಜೊತೆಗೆ ಇನ್ನೊಂದು ಮೋಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾರೆ, ಟ್ರಾನ್ಸ್ಲೇಟರಿ. ಯಾಕೆ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತಂದ್ರೆ rotational motion ಒಳಗೆ ಟಾರ್ಕ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಬೇಕಂದ್ರೆ ಈಕ್ವಲ್ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸಸ್ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ. ಬಟ್ ಈ ಈಕ್ವಲ್ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸಸ್ ಏನಾದ್ರು ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಆಕ್ಟ್ ಆಯ್ತಂದ್ರೆ ರೋಟೇಷನಲ್ ಜೊತೆಗೆ ಇನ್ನೊಂದೇನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾರೆ, ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಮೋಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾರೆ. ಯಾವಾಗ ಟ್ರಾನ್ಸ್ಲೇಷನರಿ ಮೋಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ, ದೇರ್ ವಿ ಎಕ್ಸಿಸ್ಟೆಡ್ ದ ಕ್ವಾಂಟಿಟಿ linear momentum, there existed a quantity called as a torque. So that's the reason linear momentum that again you are going to observe in the form of a angular momentum. So this is the equation. So remember, angular momentum, that is what we observe, a vector quantity, and the equation is given by L is equal to Rp sin theta. So this is the equation. So very important equations. Next, what is the relation between torque and angular momentum here? So when we observe the relation between a torque and angular momentum, there we are going to observe given by the equation like this. So external torque, so external torque that should be equals to what here, dl. So d vector L divided by dt. So this is a relation between what we can say, torque as well as angular momentum. So this is we consider torque as well as angular momentum. Next, so what is the meaning of a law of a conservation of a angular momentum? So angular momentum ಯಾವಾಗ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ, So angular momentum constant ಆಗಬೇಕಂದ್ರೆ so whenever if I want to say angular momentum constant ಆಗಬೇಕಂದ್ರೆ differentiation should remain as a 0. So differentiation ಯಾವಾಗ 0 ಆಗುತ್ತೆ. So differentiation of a constant values already we know here 0. ಇದು 0 ಆಗಬೇಕಂದ್ರೆ so ಈ term ಏನಾಗಬೇಕು constant ಆಗಬೇಕು. So differentiation value 0 ಆಗಬೇಕಂದ್ರೆ torque value should be what here 0. If a torque value is 0, so toe external value is 0, it means this implies a differentiation of vector dl divided by dt value is 0. ಯಾವಾಗ differentiation 0 ಆಗುತ್ತಂದ್ರೆ so given value should be what here a constant. So this is we consider a law of what here a conservation of a angular momentum. So how to define whenever external torque on the object, whenever external torque on the rigid body is equals to 0, whenever external torque on the rigid body is equals to 0, then angular momentum remains constant here. So total angular momentum is conserved here. So this is we consider as a law of conservation of angular momentum. So law of conservation of angular momentum here. So now based on these two quantities, very important factor that we consider as a mechanical equilibrium. So whenever a rigid body is a mechanical equilibrium, yavaga rigid body mechanical equilibrium irutta. So now mechanical equilibrium antandre totally that system should remain as a constant here, or else a rigid body should under the condition equilibrium. So there we are going to observe a two type of a motion. So the first one translatory motion, so translatory motion, and the second one there we consider as a rotational motion. So rotational motion everyone observe ಮಾಡ್ತೀವಿ. So whenever net amount of torque acting, so net amount of torque acting on the object is 0. So whenever we are going to observe a net amount of a torque is acting on the object is 0. So now we consider as a this is under a rotational equilibrium. So ಇದು ಏನಂತ ಹೇಳ್ತಾರೆ rotational equilibrium ಅಂತ ಹೇಳ್ತಾರೆ. So rotational equilibrium ಅಂತಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದೊಂದು ರಿಜಿಡ್ ಬಾಡಿ ಅಂತಂದಾಗ ಇದು ರೊಟೇಟ್ ಆಗ್ತಿರುತ್ತೆ. ಇದು ರೊಟೇಟ್ ಆಗಿರೋದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ರೊಟೇಟ್ ಆಗ್ಬೇಕಂತಂದ್ರೆ ಒಮೆಗಾ ವ್ಯಾಲ್ಯೂ ಏನಾಗಬೇಕು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಬೇಕು. ಸೊ ಒಮೆಗಾ ವ್ಯಾಲ್ಯೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಬೇಕಂದ್ರೆ ಅದ್ರ ಮೇಲೆ ಯಾವುದೇ ಎಕ್ಸ್ಟರ್ನಲ್ ಅಮೌಂಟ್ ಆಫ್ ಏನ್ ಆಕ್ಟ್ ಆಗಬಾರ್ದು, ಟಾರ್ಕ್ ಶುಡ್ ನಾಟ್ ಆಕ್ಟ್ ಹಿಯರ್. ಸೊ ದಟ್ಸ್ ರೀಸನ್ ವಿ ಕನ್ಸಿಡರ್ as what here whenever net torque acting on the object is 0, that object is ಅಥವಾ ಆ rigid body ಏನಾಗಿರುತ್ತೆ rotational equilibrium. Next one more is translational. ಯಾವಾಗ translational ಇರುತ್ತೆ ಅಂದ್ರೆ net amount of force acting, so net amount of force acting on the rigid body that should remain as a 0. ಯಾವಾಗ net amount of ಇಲ್ಲೇನೋ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗಿರೋದು ಆ ರಿಜಿಡ್ ಬಾಡಿ ಮೇಲೆ 0 ಇರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಅಂಡರ್ ಕನ್ಸಿಡರ್ ಆಸ್ ಅ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಸೊ ದಿಸ್ ಇಸ್ ಅಂಡರ್ ಅ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಹಿಯರ್. ಸೊ ಇದು ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ಒಳಗೆ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ರೋಟೇಷನಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂಡ್ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್ ಹಿಯರ್ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಅಂದ್ರೆ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಅಂತಂದ್ರೆ ಸೊ ವೆಲಾಸಿಟಿ ಚೇಂಜ್ ಆಗಬಾರ್ದು. ಸೊ ವೆಲಾಸಿಟಿ ಚೇಂಜ್ ಆಗಬಾರ್ದು ಅಂದ್ರೆ ಸೊ ಎಫ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ವಾಟ್ ಹಿಯರ್ ವೆಲಾಸಿಟಿ. ಅಗೇನ್ ಮಾಸ್ ಇಸ್ ಟೇಕನ್ as a constant here. So F is directly proportional to velocity. So force ಯಾವುದು ಅಪ್ಲೈ ಆಗಲಿಲ್ಲ ಅಂತಂದ್ರೆ velocity constant ಆಗುತ್ತೆ. velocity constant ಆಯ್ತು ಅಂದ್ರೆ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಬಟ್ ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಏನಾಗಬೇಕು, ಇಲ್ಲಿ ಲೀನಿಯರ್ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಬೇಕು. ಇಲ್ಲಿ ಯಾವುದು ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಬೇಕಂದ್ರೆ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಬೇಕು. ಸೊ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್, ಲೀನಿಯರ್ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್. ಇಲ್ಲಿ ಲೀನಿಯರ್ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಬೇಕಂದ್ರೆ ಯಾವುದು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗಬಾರ್ದು. ನೆಟ್ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸ್ 0 ಆಯ್ತು ಅಂದ್ರೆ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಇಲ್ಲಿ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಬೇಕಂದ್ರೆ ನೆಟ್ ಅಮೌಂಟ್ ಆಫ್ ಟಾರ್ಕ್ ಏನಾಗಬೇಕು 0 ಆಗಬೇಕು. ನೆಟ್ ಅಮೌಂಟ್ ಆಫ್ ಟಾರ್ಕ್ 0 ಆದ್ರೆ ಇಟ್ ಈಸ್ ಅಂಡರ್ ಕಾಲ್ಡ್ as what here rotational equilibrium. So that is we consider as a rotational equilibrium. So both together we consider as a mechanical equilibrium. So entire rigid body is under mechanical equilibrium. ಅಂದ್ರೆ ಈ ರೀತಿ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ನೋ ಆಗಿಲ್ಲ, ಈ ರೀತಿ rotative angle. So that is remaining as a equilibrium. So now the last content of this chapter, so it is called as a center of gravity. So center of gravity, so which is called as a center of gravity. So when we observe a center of a gravity, it is a point where, so it is a point where total gravitational force should remain 0. So total